So my name is John. I work as a developer, an iOS developer at Spotify, and I'm here to talk to you about one of my favorite topics, which is backend-driven UI. So as developers, we're always looking for ways to make our life a bit easier, to make our development process faster and more efficient, to make it more fun. Basically to find new ways to take us faster from an idea to something that we can ship to our users. Whether that's a brand new app that we just thought of, there's going to be a lot of inspiration these days, so I'm sure many of you will think of new app ideas. Or other features. We just heard Natasha talk about shipping more features instead of just big apps. We want to move closer to being able to ship faster. And the great news is that we've had a lot of tools created by the community over the last few years to make this a lot faster. We've had package managers such as CocoaPods and Carthage. We've had patterns such as using RX or view model or model view model. It's a bit of a mouthful. We've also had Swift, which is a big breakthrough as a new programming language, and tools like Fastlane to make it easier to ship our application to our users. So we've made a lot of progress, and things are a lot faster than they used to be. But there's one area where we still tend to do things the way we've done it in the past. It hasn't fundamentally changed as much over the last few years as other areas. And that area is UI development. Now, don't get me wrong, we've made a lot of progress on UI development as well, and Apple has provided us with a lot of great new tools to do UI as well, such as auto layout and size classes and all these kind of tools, stack views, collection views. But we're still kind of doing UI development the same way as we did it when the iOS SDK first launched. We're still kind of creating all of our UI from scratch every time, and every time we create a new screen in our app, it always tends to start as a new subclass of UI view controller. And when we do build these UI view controllers, we always tend to fill... Whoa, this is... There you go. My head is too small or something? I don't know. But when we do build these view controllers, we tend to fill them up with pretty much the same thing over and over again. We tend to write these manual implementations of UI table view data source or delegate, or UI collection view data source to delegate, do data loading, do caching, and all kinds of things. And we tend to fill up our view controllers quite fast. As we all know, we've all created these massive view controllers at some point, right? With way too much logic inside of them. So there's a lot to be done every time we create a new screen in our app. And to show you, I just want to show you a very simple example. Let's say that we want to build a very simple app that just displays a bunch of cities. It's just a table view, normal UI table view, no custom UI at all, just the classic old UI table view that just displays some data. And we're going to load this data off from a backend because it would be a bit boring to just ship an app that displays a static list of cities in a table view. I mean, we could do that in 10 minutes, but I don't think many users would love that app. So what are some of the things? Oh, I'm getting ahead of myself here. There we go, and we want to talk to backend. Oh, there you go. Now you already had the spoiler, but yeah. So what are some of the bare minimum things that we need to do in order to build this extremely simple app? Well, you just saw it before. Well, here it goes again. So there's quite a lot of things that we need to do in order to build this extremely simple UI. And again, we tend to do all of these things from scratch every time we create a new UI view controller subclass. We have to do things like JSON parsing or caching, setting up our table view, implementing table view data source, doing all these kind of things over and over again. And sure, we might have some libraries to help us out with, for example, JSON parsing or caching, but we tend to implement it manually every time for every single use case. And that gets us sometimes into a bit of a tricky situation when, let's say, we build this app. It's very clear that this app didn't have a designer involved. It doesn't look very, exciting. It's just a table view, right? So let's say we call up one of our designer friends and we ask him to take a look at this and give us some ideas. And he says, you know what you should do? You should just take 2 cities and make them featured in the top. You should just create 2 image views in the top and give the UI a bit more life. Well, that sounds great. This sure looks a lot better than what we had before. But it does give us a bit of a problem because we are using UI table view, which is super great for building lists and having editing support and cell reuse. But taking these kind of card-like views and putting them inside a table view is a bit challenging. And this is actually, I would say, pretty much the #1 question asked on Stack Overflow is how to mix a table view with a collection view. And there is all kinds of crazy hacks to do it, like take the collection view, put it in a table view cell, and manually scroll it, and you disable the scrolling in the user interaction, and then it's going to work. Well, I don't know. So there are many ways we can do this, but most of them involve some kind of a little bit of a hacking to get it to work properly, because they don't naturally play very well with each other, the UI table view and UI collection view. It gets even more complicated as our app continues to evolve and we continue to add new features. Let's say we want to add a social element to our app and be able to display a list of the user's friends in line in the list of cities. Well, that would be pretty cool. But again, it involves us to kind of create these hacks on UI table view where we have to create like a custom cell that has a collection view or something inside of it, or just a static array of images. But then what if there are only 3 friends and not 2? Gets us into some complex situations. So as we can see from this very simple example, it's kind of hard to scale up our UI. And every time we do it, it gets more and more complex. And again, that's why we end up with these massive view controllers that have a lot of state, a lot of if and else statements, and they're really hard to test. So instead of doing all of this, and instead of creating these view controllers all the time from scratch, wouldn't it be pretty nice if our UI code would look like something like this? Instead of having to create all of these things manually, wouldn't it be cool if we can just declare what we want to display, and then we'll have a system to display it? Well, that'd be pretty neat. That way we could just say, I want 2 images in the top, then I want to have 4 rows, then for users, 3 rows at the end, and then I'm done. And that it will all be taken care of for us. That means that what we did before, adding the images and adding the users, is just a matter of inserting new elements into this array. That would be pretty sweet. And wouldn't it be even cooler if we wouldn't actually have to put this array in our app and hard-code it and have it be the only layout configuration we could have, but rather have our backend actually return this array as our backend response. So rather than just sending the data that we need, it would actually send this ready-to-use array that we can just render. And that's what backend-driven UIs is all about. In fact, at Spotify, we've been hard at work migrating to exactly this type of architecture over the last year. And we've converted more and more of our app, and at this point, we're at, I think, about 50–60% of our app uses this architecture. What you see on the screen are very different UIs. They behave differently. They render different types of content. They have headers or not. But these are all the same UI view controller. These are all the same UI collection view data source. They use the same data loading code, image loading code, etc., etc. They're basically the same client code. The only thing that differs between all of these UIs is what the backend sends as the data. So they're really just a representation and a rendering of our backend data. All right, so how do we get here? I mean, obviously it wasn't just something we could do in a day. And it required some fundamental changes to the way that we do our UI development. So there were really 3 key things that we needed to change in order to make this happen. And I'd like to walk you through them now. So the first thing that we needed to do was, so in these UIs, we have a lot of different models. We have a lot of different ways of expressing an entity. We can have playlists, albums, artists, etc. So what we needed to do first, #1, was to create a shared data model that the backend can use to communicate to the client. In order for the backend and the client to understand each other, we need to kind of make them speak a common language. And in order to enable that over a network, we needed this shared data model to be fully serializable. We didn't want to rely on things like creating binary representations of classes and sending them over the wire, because that becomes tricky quite quickly. Instead, we chose JSON as our transportation format, not because it's the most efficient or most clean solution, but it's readable, it's easy to debug, and it has lots of tools associated with it. But if we look at our simple demo app from before, we can see that just in this extremely simple app, we already have 3 kinds of models. We have an image model on the top, which has an image URL property. We have a city model, which has a name and then a country associated with it. And then we have a user model, which also has a name and an image URL. So we can see that these have slightly different pieces of data, and they're named a bit differently. So we couldn't just create cases for all of these things because it wouldn't really enable the level of dynamism we're looking for. Instead, we needed to create a shared protocol for it. And we chose to name it component model. Instead of creating all these custom models for every entity, we had a shared model that we could use to represent anything. And then we encapsulated these component models in a view model, which is a quite common pattern now on iOS. So what did this component model contain? Well, instead of containing things like name and country, it contains more generic fields like title, subtitle, image URL, icon, etc. Things that we can use to express many different types of entities, not only a single one. So the shared data model was the #1 thing that we needed to implement. The second thing we needed to do was to create protocol-oriented views. Now, I'm a huge fan of protocol-oriented programming, and we can see it all over the Swift standard library, how protocols are being used to eliminate code duplication and to make things a lot more streamlined. But in UI development, we don't tend to do it that way. We tend to create these very hardwired behaviors between a superview and its subviews. It's superview that lays them out and has a very close relationship to them. And that makes it, again, hard to experiment and try out new different ideas. And we wanted to apply the same concept with protocol-oriented programming to UI development. So if you look at one of the views, here's the browse view from the Spotify app. What we did was that we sliced it up into pieces. Instead of creating this very tailored UI for browse, we just created these segmented pieces of UI that we call components. And components are just a protocol-oriented way of building views. They don't know about each other, and they're completely separate and isolated. But how are we going to get all these components to be rendered together? We can't just throw them in there and hope that the layout will solve itself. So we built a custom layout on top of UI collection view, because UI collection view is super powerful. If you haven't tried it before, I really urge you to try to build your own custom layout. It's a lot of fun, and it's kind of a functional way of defining the fun. I think it's fun. I have a weird hobby. I like UI collection view layout. I also like JSON parsing. I'm super weird. Anyway, so you can really create your layout in a very functional way, which fits this paradigm very nicely. So we started out simple. We created a protocol for a component, and we started out with just a view property and a method to load that view. We were a little bit inspired by a UI view controller that lazily loads its view, because that way we can create instances without having to allocate UI. And then we're going to take that view and put it inside of a collection view cell so that we can render it all nicely together. Next, what we needed was a way to configure this component with a certain model. And here's where this component model comes in that we talked about just before. So we added a configure with model API that the component can implement. We then started thinking about layout. Layout was probably the most complex thing to solve here, because you have all these isolated components that need to be able to be laid out in a nice way. And the first piece of the puzzle is size. So we added a preferred view size property to the component protocol that the component can then decide what preferred size it would like. But size is just one piece of the layout puzzle. And the more tricky part is how all the components will fit together on the screen. We started out by asking the component to provide us with margins, and then we would just use those to compute our collection view layout. Well, that didn't scale very well. It didn't work very well, because that kind of made the component have to be aware of each other. We had to have rules that said, oh, if there's first a row and then a card, then we have this margin. But if it's just 2 rows in between, there's no margin. And that meant that the row component and card component had to be aware of each other. It wasn't very nice. So we came up with a more abstract system that lets components be fully decoupled while having a central place, a single source of truth for layouts. And that we call layout traits. Layout traits are just a way of describing what your components look like and how they behave in a layout. You will say things like it's a full width or compact width, or it's stackable or not stackable. And then we have a central place. In this case, it's a UI collection view layout, where we just compute the layout for the view according to these signals. So that's how we solved the layout problem and how to get these views to work nicely together without having to be aware of each other. The final piece of the puzzle was how to deal with this, or how to interact with this from an API perspective. And for that, we built a declarative API on top of these technologies. So we started out, again, simple. In the beginning, this way of doing things was really just a rendering of JSON. We just had a view controller, it was initialized with JSON, and it would just render it on the screen. It was very simple, but it wasn't very exciting. I mean, we all know that a UI is more than just a rendering on the screen. You need to be able to move it around and interact with it, and it needs to be able to respond to things, etc. So we need to support things like interactions, if the user clicks on something or scrolls the view. We need to support reloads, because if, for example, a user deletes an item or a new item comes in from the server or some underlying data model changes, we need to be able to react to that to reload the view. We also built an actions API that enables components to transmit actions to other pieces of code, again, being fully decoupled so that they don't have to have a strong dependency, but they can just fire actions whenever something happens in them. And finally, whoa, we're always going a bit too quick on this clicker. Or I'm just too eager. And finally, we needed to support local data as well, because even though backend-driven UI gives you a lot of flexibility, there are certain things that the backend cannot know about. For example, if we use accelerometer data in our app, it's very hard to have that in the server. It comes from the device, so we needed to support that as well. To support all of these things, we built a declarative API that we call content operations. And content operations are just like your average operations. They are chainable, and they can be completely atomic and work on their own. You can see that kind of a pattern here is that we want to have very atomic pieces of code, atomic components, atomic content operations, which enables us to move fast with a large team, and it enables us to add and remove things very easily. So, like other operations, a content operation has input and output. And the input is what we call a view model builder. If you've done programming in other languages, such as Java, for example, you might be familiar with the builder pattern. On iOS and other Apple platforms, or in Objective-C and Swift, we tend to use mutable models. We didn't really want to use mutable models because they tend to be a really big pain. Sometimes you end up accidentally using a mutable model where you thought it was mutable, and then you might end up with an undefined state. So we opted in for the builder pattern, where a content operation can just build the view declaratively. And then the output of the operation is the content that it's added to this builder. And the good thing is that because we use the operation paradigm here, we're very, very free in terms of how we execute our code. We can do things like talk to the backend and have this fully backend-driven UI, but we can also just run local code and add content programmatically. And that way, we can support both an offline use case and be able to combine local data with remote data. So to sum up, the three things that we needed to change or needed to implement in order to move to a backend-driven UI architecture was a shared data model where we have a contract between the client and the server. Protocol-oriented views that are fully decoupled and are not aware of each other and instead just conform to a single protocol where we know what's going to happen. And lastly, a declarative API that enables us to build these views both in the backend and on the client side. So what we did was we did these three things, and we wrapped them together as a framework, and we call it the Hub framework. And the Hub framework is because we're now building, instead of building these tailored, hardwired custom views, we're now just building hubs of components and hubs of content. And that's really what our UI is all about. And what I'd like to do now is just show you a quick demo of how it is to work with backend-driven UI and the Hub framework. Yes, I'm the crazy person who does live coding in front of 300 people. Yay! All right, so what you're looking at here, can you see this, by the way? Is it screen size okay? All right, let's go presentation. This is okay? Awesome. So what you're looking at here is a content operation. Here we have the perform method, which takes a view model builder and some other metadata like the connectivity state, etc. And then we can do work based on that. So here I'm actually building the content for my app, which I'm about to show you, in code. So this is not backend driven just yet. So let's take a look at how it looks like. I took some inspiration from this conference because I was excited to come here. So I actually built a little app that shows the schedule of the conference. Now, I know we already have an app for that, so it was just for demonstration purposes, really. But you can see here that this is a normal native view. It's not a web view or anything crazy like that. It's a table view cells. You can interact with them, scroll them. It's smooth and fast. And this view is currently built here in this content operation programmatically, but it's very declarative because what we're doing here is we're looping through our events, and then for each event we're creating a label builder where we're just creating the label, which is the time. And then depending on what the event is, if it's like a talk or a coffee break or a lunch, we are just switching on the event type and adding different content to our view depending on what the event is. So that's one way of using content operations, but let's go ahead now and make this backend-driven. I'm going to go ahead and delete all of this, except for the title, which I want to keep. And then I added a convenience API on URL session called load schedule. And that's really, I can just go inside that method. No, Xcode doesn't work, like always. So I'm going to go here, and I'm just going to show you, it just loads a local JSON file on my local host server that I have running. So it's really just a thin wrapper on the URL session. I'm going to check if I get data back from the server. Hopefully I will, because it's a local server. And if I get data back, I'm going to take the view model builder, and I'm going to say add JSON data. So I'm just going to add this JSON data to the server, to the view model builder, and then I'm going to move this delegate call into the completion handler for the URL session, so that we notify the framework that we finished our content operation. So let's go ahead and run this, and jump back to the simulator, and we can see we have the exact same view, but we just deleted all of our code. What? Is this magic? Well, it's not. Kind of. I'm just going to go ahead and here make this a bit bigger for you as well. This is now our UI code. All of our UI now is rendered from this JSON file here. We can see that we have here the schedule, 8:30 it begins with. It says registration, 9:30, keynote, etc. And that's exactly what we have in our UI. In fact, we can do some fun things with this now. We can, let's say we wanted to experiment and add a header to this view. We can do so super easily. Let's just add a new component. We just add a new entry here. It's going to be a component with ID image. Let's see. And it's going to have some images, or actually just one. It's going to be a main image. And it's going to have the URI, localhost 8000, because it's my awesome server. And it's going to be banner.jpg. I'm just going to save this file, and then I'm just going to jump out of the app and back in. And boom, there we go. We have a banner in our app. It's that quick to change our UI, and this can be done completely from the server. Yeah, thank you. Thank you, thank you. We can also use this to iterate on the core functionality of our app. Let's say we wanted to only show the things that haven't happened yet. So we're going to go ahead and delete the talks that have already happened here from the back end. We're going to go here and just delete a bunch of components here all the way down to, that was a great talk, I really liked that. That was also really good. Here's mine, or coffee break first. Yeah, that was good too. And here's mine, so I'm going to delete those things. Again, save, jump back out, and jump back in. And now we can only see the upcoming events, and we can update that dynamically from our back end. One final thing I want to show you before I'm running out of time is just that we can do even crazy stuff here. We can take this simple, for example, this 1210 label here, and we can just turn it into a search bar by just saying ID search bar instead, jumping out and jumping back in, and now that label is a search bar. So you can do a lot of fun stuff with this. All right, let's jump back to the slides. Thank you. All right, so I am personally super excited about this architecture. At Spotify, this has been a game changer for us. We've been able to move so much quicker, do so much more testing, change the functionality of our app very, very easily. And we think this is a really cool thing to do, and that, yeah, it's making things a lot faster. So one thing I've heard from a lot of people in the community as I've been talking about this is, You know, it's great to hear this 30-minute presentation and a very high-level overview, but we want to see the code. We want to see the source code. You know, it's like we want to be able to turn this inside out and see how it works. Well, I'm super happy to say that as of 2 weeks, the Hub framework is completely open source. Thank you. And not only did we open source the code, we open sourced the entire commit history, and we open sourced our roadmap as well. So we're working completely in the open, and you can see how the framework is evolving. You can try it out for yourself. There's documentation, there's a demo app, etc. All right, that's it. If you want to check out this framework, you feel free to go to my GitHub profile. I have a link there to the Spotify repo where the Hub framework lives. I'm also at Twitter. I'm at John Sundell. If you want to talk to me about this kind of things or other things related to iOS, I'm always super happy to talk to the community. I love that about being an iOS developer. And also, if you want to just catch me in the hallway, maybe get more of a demo, I'm happy to show you. But that's it for now. Thank you very much.